Hello, good people. It's Mr. Gilbert here, and today we are going to talk about something interesting because you will learn about the interaction between atoms. Okay, so before we start, just make sure that you understand about how to determine the proton of the element and how to determine the neutron of the element, how to define the electron configuration electron configuration and then how to determine the valence electron. Okay, so just to refresh, so I take one element, for example sodium is a metal, and sodium has 11. The atomic number is 11. So we know that if the element has a atomic number of 11, it means the proton of this element is 11 also, and so does the electron. So the number of the proton is the same with the electron, since this element in the periodic table is neutral. Okay, so how to define the electron configuration. So we take this 11 electron. If you still remember about the atomic structure, so you draw here the nucleus, and then there is there are shells surrounding this nucleus. The first shell is only provide for maximum 2 electron. The second shell is only provide for maximum 8 electrons, and the third shell is only provide for maximum 18 electron. So if this sodium has 11 electrons, first you put 2 electrons in the first shell, and then it means it's 9 left. So you put another electron in the second shell. 4, 5, 6, 7, 8 enough. So it reached maximum electron. It means there is 1 electron left. So you put here in the last shell. Okay, so what is the configuration? The configuration is the number of the electron in each shell. So you count here the first shell has 2 electron, and then the second shell has 8 electron, and in the third shell it has 1 electron. So it means the configuration of a sodium is 2, 8, and 1. Then it's very easy to determine the valence electron of the sodium. So you just take the last electron of this element. So the valence of sodium is 1. So valence is the outermost electron that the element have. Right. So that is about the introduction before you start to go to um, the interaction of the atom, or we call it as bonding. So the element has an ability to bond with other element to make them stable. That's why the last group or family of the periodic table called as noble gases, and they have the most stable element on a periodic table, so they don't need to bond with other elements. Let us talk another elements. Okay, so here I take one element, yeah, sodium. All right, but before we start to bond between the elements, I want to tell you about the type of bonding. So there are three types of bonding. The first one is ionic bonding, and the second one is the covalent bonding, covalent bonding, and the third one is metallic bonding. Okay, so we talk about the metallic bonding later in other classes, and we just focus to ionic bonding and covalent, but today we are going to talk the ionic bonding first. So the ionic bonding is a bonding between a metal and non-metal. So ionic bonding is a bond between metal and non-metal. So you have to know which one is metal element and which one is non-metal element. Okay, and then uh, the ionic bonding tend to be give or share. So sorry, they give and get or lose and gain electron. So what does it mean? Let us start. The ionic bonding. So again, the ionic bonding is a give and get or lose and share. So we take one example. I take one element from the alkali metal, lithium, and the non-metal from the halogen gas, fluorine. So lithium has 3 atomic number and fluorine is 9. The atomic number of fluorine is 9. So again, you know how to find the configuration. So first you have to make a configuration. The configuration is 2 and 1 because it has 3 atomic number. So the valence electron is this, is 1. But for fluorine, the configuration is configuration 2 and 7. The first shell is 2, the second shell is 7. So the valence is 7. Okay, you're done with the first step and you go to the second step. The next step is you will make a Lewis structure. A Lewis structure. What is a Lewis structure? The Lewis structure is a dot and cross model to represent the atom of the element. So this is the example. Again, here you want to bond the lithium with fluorine. It means you just draw Li here and F here. And then you need this valence, you need this valence, this valence, and this valence because you must draw the element here. So for lithium, we draw one electron only with the dot. Okay, and for the fluorine, because it has 7, you have to draw 7 electron. Okay, I draw with cross. Okay. Okay, how to draw the electron. Okay. Okay, I repeat this. So how to draw the electron if it has more than one is you do it one by one in the clockwise. So you draw like this. You draw this. 1, 2, 3, 4, 5, 6, 7. So why you have to draw like this? Because if you draw like this, we will know that there is a single electron here. So this is a single electron of fluoride, and this is a single electron of lithium. So maybe you are okay if you are single, but not for the element. They have to make a couple, they have to make a duplet or octet electron duplet or octet valence electron, so they will have a stable element. Alright, so don't let them be a single. So what to do then? Again, that ionic bonding is a give and get. So this metal element, better to give this electron, to another element, and this fluorine, this non-metal electron, is better to get electron from other element, because they will save energy if they just gain one electron, then rather than they have to lose 7 electrons. So metal, the group 1, is tend to give, while non-metal, group 7, is tend to get. So this lithium, the lithium gives the element into fluorine. So next step is you draw again your lithium and fluorine. Okay. Remember, so now this lithium lose the one valence electron here. So it lose this valence electron. So now lithium have only 2 electrons left. So you draw here 1, 2. Alright? Is it a problem? No. And now lithium has a duplet valence electron, means lithium now stable. And how about fluorine? So fluorine, again, you draw here 1, 2, 3, 4, 5, 6, 7, and now the fluorine get one electron from the lithium. So now fluorine has 8 valence electron. Okay, so both of them now stable. Okay, their life is happy now. And then if it's happened, so this lithium and fluoride form a compound called a lithium fluoride. So this compound is neutral. Lithium fluoride. But when they react with water, the lithium will split, will be a positive ion, and the fluorine will be a negative ion. So while lithium be positive, remember that this lithium lose 1 electron. So now the proton of lithium is more than electron. It means this lithium is more positive. While fluorine, the electron is more than the proton, so it means the fluorine is more negative. Okay. So lithium has positive charge and fluorine has negative charge. Metal has positive charge, non-metal is negative charge. Metal is positive, non-metal is negative. So that's all from me about